So we can have these buttons in here. Excellent. I guess I should probably do like generate this automatically, which will make our life a lot easier. So we're gonna make a new component, and we're gonna, not a folder. We're gonna make a new script. This is gonna be called build toolbar build buttons. It's fine. I need more coffee. Bam. Good stuff. So what I'm going to do is I'm going to delete these buttons that are down here. I'm going to take one of them and make it into a prefab, which I'm going to call build button. It's fine. And we're going to drop that. I don't think... Hold on. I got to split up my prefab organization a bit. This is going to be something like ship parts. So I'm going to take all these bad boys, move them into ship parts, and then I'll make another prefab category for UI elements, like that. Okay, so the build button is going to get dragged into UI elements over here, which is going to be great. Then I can get rid of one in the seed, and then the toolbar build buttons component is going to get dragged into this, and then we'll open it up into mono develop. And what we're going to do is we're going to set up a couple of publics. Public game object. This is going to be the build button prefab. And then we're going to have some sort of public game object array, which is going to be all the ship part prefabs, like this. Okay, good. So in our button group, as soon as it comes in, we're going to give it a link to the build button prefab. And for the ship parts, we have an array over here. The easiest way to do this is this. With the button group selected, hit the little lock at the top of the inspector. By doing that, it means no matter what I click on, it doesn't change what we're looking at in the inspector. By the way, did you know you could have more than one inspector window? Very cool for this kind of nonsense. So now it will always show us the build button inspector, which means over here I'm free to do this. I can click here, shift click down to the bottom to select all the ship parts. It still has that inspector pane, which means I can drag all these guys into the ship parts prefab. You have to do it like on the name here, and it'll populate this array. Really handy shortcut. Although I just realized we don't actually want root in that list, so I'm just going to go and drop the size down to 4. There we go. So now thruster, cube, rectangle, triangle, all in the list. Wonderful. And then we're going to go back to our script, and we're going to say this. On the program start, populate our button list. So, for each game object, ship part in ship part prefabs. For each one of those buttons in our list, we're going to add, for each ship part in our list, we're going to add a new button to our display. So we're going to instantiate the build button prefab, and we're going to specify that its parent should be us. We are the parent of this, right? The toolbar build button is going to be the parent of all these buttons. So let's first of all, let's see what happens if we just run this. I'm kind of curious myself. Hit play. Ooh, we get a bunch of buttons. Hey, excellent. Now, we're going to need to make some changes to those buttons, like, for example, maybe label things. That would be pretty handy. So we're going to grab an instance of this. We have to make sure to cast this to game object, because instantiate just returns a generic object. And then in here, we have to do user interface stuff. So we have to make sure to include Unity engine.ui. And by doing that, we can refer to things like get component in children. We're looking for a component of type text, which we needed to include the UI for that. So we're going to find a text component somewhere in here, which is actually the button label. And then that means we can set button label dot text to be equal to, say, maybe the ship parts prefab dot name. Now, we should probably be checking to make sure none of these things come in null, but let's pretend it works. Excellent. Now the buttons are correctly named based on our prefabs. Ooh. Nothing still happens. How do we get to the next step? Well, we need to make it so that when you click on the button, something happens. What is that something? Well, what we want to do is when you click on the button, we actually want to change which object will get spawned by our mouse manager. You dig? So let's figure out a couple of things here. Let's find a copy of our mouse manager. Mouse manager. And we're just going to use dot find object of type mouse manager. So this will check the entire scene and return the very first, specifically it returns the component on an object of type mouse manager somewhere in your scene. There's always big warnings about this. Oh, it's not very fast. Okay, you don't want to do this 1,000 times in each update. But in your start, no, it's perfectly fine. This is a great way to grab it, and it stops you from having to make public mouse manager here, and then remember to link it in your inspector. No, just have it find it in runtime. If you're only doing this once, or once every few frames, it's plenty fast. Don't worry about it. So now we have our mouse manager, and what we're looking to do is when this button gets clicked, you know where it says go? I'm going to rename this to this is going to be called the button game object to make it more explicit. When this button game object gets clicked, we just want to change mouse manager dot the prefab to spawn. So how do we do that? Well, button game object has a component called button, right? The button, boom, dot get component button. And this has something, the button dot on click, has an event ready to go over here. It's a little funny because you don't just modify on click because it's a Unity event, blah, blah, blah. You just add listener. And what this is looking for is a function to call. Basically, it wants to call a function with a signature that looks like this. Void foo, right? Returns nothing, demands nothing. When the button gets clicked, called foo. And we can test this. Debug.log foo. Dun, 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 dun. Okay, excellent. So if I do that, no compilation errors. Okay. Okay, warnings are fine. If I click this, it should say foo in the log. Yay, it says foo! In fact, they all say foo. I pity the foo. So this is how you respond to this button click, is by adding a listener. Now, it's worth noting, this is exactly the same if we had the button in our scene. Oh, we're still locked over here in the inspector. Let's make sure to unlock that. If we go to the button, see where it says the on-click list over here? And you can add listeners and things like that. That's basically what we're doing here. But, except we're doing it at runtime. Okay, so that's cool. We can do foo. But foo, this function that gets called here, can't have any parameters. Like, if we wanted to do something like game object to spawn, right? And then how do you specify it? Because all you're doing is you're not calling the function here. You're just giving a function name. Now it has the wrong signature. We'll get an error. So now we got an error because it doesn't match the signature that it's looking for. It has to be a completely anonymous function. Luckily, so how do you get the right game object? Well, I guess we could make a bunch of different ones. No, we're just going to use an anonymous function over here. This, my favorite thing. This is an anonymous function. This is a function. Debug.log bar. This is a function that takes no parameters and runs some code in here. And then returns nothing. So now if I click on the button, bar shows up. So we can do more things in here. For example, hey, when this button gets clicked, here's what I want you to do. I want you to go to Mouse Manager and the prefab to spawn, I want you to set it to this ship part. Now, this will not quite work the way we wanted because of closure. But this is our function. Our function is just going to change Mouse Manager and set the ship part to something new. Okay, so let's hit play. And let's say we want triangle. I click on triangle. In theory, the ship part to spawn has now changed. Ah, we're spawning a triangle. Hooray! And another triangle. And another. Oh, that's fantastic. Now I want to click on a rectangle. And I'm going to click. And it's going to spawn a triangle. And wait, what? What? Who? Huh? Why is it doing that? Closure's a very hard thing to explain. Maybe because I don't properly understand it. But basically, right over here, this function will get called sometime later, right? It doesn't get called now. When this button gets clicked, this function gets called, and these variables are used. Well, ship part is one variable. All of them are setting the prefab to spawn to ship part. And every time we go through this loop, we change what's inside of ship part. But it's exactly the same ship part, which means this will always be whatever the final button is, literally the last button to spawn, which in this case is triangle. Because every time, at first, if we only had one button and it said thruster, and we click this, it would be thruster. The problem is that as we add more buttons, each one of these is linking to exactly the same game object ship part, and everything goes kind of weird. Whereas if we did something, and that's because ship part is actually defined outside of the loop. If we were to do this, and let's say I do ship part 2. Ship part 2 is equal to ship part. Now, these are reference variables, so at this point, they're both pointing to exactly the same ship part prefab. But they're different variables, and if I do this, then this is only pointing to the ship part 2 that exists within this iteration of the loop, this one here. The next time it loops through, we're going to get an entirely different ship part 2, which is then going to get mapped here. Anyway, I know I'm shit at explaining closures, and maybe there's not a good way to explain it. But it means that if I click on triangle, I get a triangle. But now if I click on rectangle, I get a rectangle. And if I click on cube, I get a cube. And if I click on thruster, I get a thruster. Now, this isn't something that you wouldn't notice if instead of doing the for each loop this way, if instead we did something like, let me just comment this out. If I said for I equals 0, I is ship part prefabs dot length, like this. And then inside of here, again, it comes down to the insidiness, right? If instead I then said here, ship part is equal to ship part prefabs I. Again, the important part is that we are defining the variable inside of the loop instead of outside of the loop. Either way, this will work perfectly fine. And technically, there's a little bit less garbage collection because we're not using a numerator, etc., etc., etc. Oh yeah, that's the default. So now if we go to, say, thruster, bam, 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 bam. This is going to be a fast one. And then rectangle, boom, I guess in the middle. There it is. It's a little hard to click on them when they're far away. Just because of the way the physics system works. Now, what would be cool, and we don't have this support in here right now, is if we could rotate the triangles. Because what I would like to do is sort of rotate them inwards and then put a cube in the middle. Get sort of a pointy front thing going on. But we don't. We also have the ability to undo or delete things. I will leave that as an exercise to the viewer. But hey, there we go. We got that going on. Excellent. Now, right now, this is not physics enabled. If I went onto our ship root over here and added a rigid body component, the ship will fall. Oh, sorry, it already has a rigid body. Oh, but it is kinematic. If I turn off is kinematic, then the ship will fall. Ah! Non-convex mesh colliders. Oh, no longer supported with rigid bodies. Oh, interesting. The complaint there is because we had a thruster in our ship, and our thruster has a mesh collider on it, right? Which becomes very obvious if I turn off the mesh renderer. You can just see the collider back. And I forgot that you can't, in Unity 5, because they updated to a new version of PhysX, it no longer supports non-convex mesh colliders. This is a concave mesh collider. You can tell because it's like, it goes inwards like a cave, right? A convex shape never goes inwards, and you can force a mesh collider to be considered convex. And even if in reality your mesh is actually convex, if you don't tell Unity that it's convex, it still won't work. But if we go and turn this there, what it's going to do here is it's going to simplify. Well, its job is not to simplify the mesh collider, but it is going to guarantee that it's got no inward pointing bits. This is much, much, much faster. And even in old versions of Unity, a mesh collider couldn't collide with another mesh collider if they weren't both set to convex. Now, Unity just doesn't even support non-convex mesh colliders with its rigid bodies. And you know what? I think that's fine. So we're going to go ahead. I just turned on that convex bit. I'm going to go and apply the changes to the thrusters. That actually will be a good idea in general. And so now if I go and add a thruster over, oops, thrusters over here, my bad. Thruster. What have I done? Did I like move? I left the mesh renderer turned off. I'm like, why can't we see it? Right, that makes sense. Thruster, drop it in the scene. Turn on the mesh renderer again, so we can actually see the thruster. Apply, delete, thruster. There we go. Okay, now we can see the thruster again. I thought I broke something horribly. And now if I were to go to the ship root and turn off is kinematic, no errors, and it just drops because it's affected by gravity. So what I want to do here is, first of all, I think this is going to be a spaceship game. So probably no gravity most of the time. Now I could just turn off use gravity, but I think it's better if we go to Edit, Project Settings, Physics, and I just set gravity to be 0 everywhere. I think I like that a lot better. Now it's still, I think, a really good idea when you're making changes to an object. You probably want kinematic turned on here, because otherwise I think you would end up with some amount of weirdness. But so we do this. Excellent. And again, we turn off is kinematic. It's not going to fall because there's no gravity, but it would be affected by all sorts of forces of physics. If something were to bump into this at this point, it would go and, move slightly to the side. More importantly, we could give it a little boost. So let's say, we add a script to our thrusters. All right, so we've got this game object thruster. Let's make a script called, I don't know, thruster, and add that. Oops. Add that over here. So it's got a script on it, and let's make it do something very, very simple. Let's make it so that if you're holding down a key, let's say the space bar, whatever, just arbitrarily. If you're holding down the space bar, the thruster fires. So where do you do that? Well, since it's a physics thing, right? We're going to be adding a physics force. You should do that in fixed update. What's the difference between update and fixed update? Update runs every visual frame, right? So if you've got a really fast computer with a really good video card, it could run, over 100 times a second. Fixed update runs immediately before each tick of the physics engine. This is where all changes to physics should happen. There's an exception. Totally instantaneous physical effects can be done in normal update, but it's probably less confusing if you still do them in fixed. All right, so they run on separate clocks, which is actually quite a good thing for all kinds of optimization, multi-threading, yada, 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 yada. But there is the weirdness where, let's say, so by default, the Unity physics system is set to run 50 times per second. Okay, you can change it. There's a value. It's very easy to change. You go to Edit. Since it's done compiling, Edit, Project Settings, Time. And you see the fixed time step over here? This is how much time there is between each physics tick. So you can increase that if you need super precise physics, which 99% of games don't need that. And if you're doing something that's super physicsy based, like a racing game or whatever, you might not even want to use the built-in physics engine for all the things. I don't know, whatever. But you can tune that if you want. But it comes up because it's possible that you will get multiple updates in between fixed update, or if your computer's video card and everything is quite slow and you can only handle 30 frames per second because, I don't know, you like to pretend you're on a console. I'm not sure, right? And you're only doing a visual update 30 times a second, but you kept the physics time step higher, you could get multiple ticks of the physics system in between each visual frame. That's fine, but it's important to understand that timing. One of the side effects, and I've said this before, is if you're in the fixed update and you use input dot whatever, let's say get button down, get key down, get mouse button down, get any of the down or ups. Down and up only returns true if and only if the button or the key or whatever it was pushed down this frame, and that's only this visual frame, okay? it's possible, depending on how the timing happens, that fixed update might actually miss the update where the button went down. Because if on update, it was like, yeah, the button went down, good, we did this, and then we're running a second update, and then the physics tick goes, well, that physics tick, because 2 visual frames have gone by, will never know that get button down worked. Alternatively, get button, or get key, or get mouse button, will always work, because that just tells you, right now, is it currently being held down, yes or no? So you could do those in fixed update. But a lot of times, what you may want to do is check to see if the button is pushed down in update, set a flag, check for that flag in fixed update. For us, I think it's going to be fine. All we're going to do, we're probably not going to use update itself. We're just going to use fixed update, but I'll leave it in there so my comment is still there. We're going to say if get key, and then it wants a key code space. So we're just checking to see if it's being held down, which is safe to do in fixed update. So if the space bar is held down, we're going to fire off our thruster. So how are we going to do that? Well, that's a good question. Ultimately, what we're looking to do is we're going to have some sort of rigid body. Okay? And what we're going to do is we're going to add force. We're going to add a physics force, and specifically, we're going to, not this one, sorry. We're going to use add force at position. Normally, it's not what you use. A lot of times, add force is fine. Add force adds the force at your center of mass, which 99% of the time is exactly what you want. But here's not what we want. We want to add the force at the thruster's location. So, do comments affect performance? They affect the performance of the speed of the video. Because imagine you've got a ship and you've only got one thruster over here. So you want this thruster, when it lights, not to push the whole ship forward. You want it to go sideways. Because it will look cool, right? Because that's what you want. You want the force to come out of the actual thruster itself. So we want to add the force at the position of our thruster itself, which is fine. These are in world coordinates, which means we say our transform. So I'll say this transform dot position. Position is in world coordinates. And then we are going to, oh, sorry, it's the force first. So, again, let's do a vector 3, the force. Use the force. All right. I'm going to apply the force at the position where this thruster is. That's it. So long as the spacebar is held down, we're doing this. So add force at position. This normal mode is good for things that get applied like constantly. Like if your thruster is turned on, then every tick of the physics update, you're just adding that force. That's fine. You do have a few extra modes to put this in. Force mode over here. Force mode. So the default is force mode.force, which is what we're doing if we don't do anything. That's good for every frame. There's also, say, the impulse one, which is very common. Impulse is good if it's a sudden, instantaneous, just happens in like that single moment. Might be good for an explosion or whatever. And that is the one example of something that might not be bad to do in update, since it is just a single one-time thing. But force mode.force works really well if it's supposed to be something over every frame. And I might be lying to you about exact use cases, but we're just going to leave it off. And in any case, do that in fixed update. So we're going to add some amount of force in there. Good. Excellent. What is the force going to be? Well, this is going to be a force that's applied in the direction that the thruster is pointing. Trying to remember our orientations. We may have to do an inverse on this. Trying to picture things. We'll figure that out. So what we want to do is we want to apply some force in the direction that the thruster is facing, which is this dot transform dot forward. That's our forward direction. Again, we may have to inverse this. We'll figure it out. Times some sort of float, which is going to be something called thruster strength. 10. It's going to be 10 strong. I don't know what 10 strong will represent in this. It's going to depend, of course, on the mass of our ship and all kinds of things. So in whatever direction our thruster is facing, we're going to apply thruster strength amount of force, and we're going to feed that in there, and that's good. So how about the rigid body? Well, here's the tricky bit. Our thruster doesn't have actually a rigid body on itself directly. Our thruster, if we... Yeah, use of unassigned variable, equals null. Just be quiet. It's going to be fine. Don't do what I do. All right. So if I go and throw a a thruster. Right, I have buttons now. There. Oh, did I still have a thruster in the scene? It's like, what's going on there? Let me delete this guy. Delete. Play. All right. Put a thruster. Nope. Thruster here. Right, and then we look at the thing here, our ship root. Right, the ship root is the thing with the rigid body. Our thruster is buried way down here. It doesn't have a rigid body. It's way up on its parent that's got it. So we need to get this rigid body. We could use a function that sort of recursively goes up the parent tree to find it, but in this case we know that it's always going to be on a root object, because that's how we're set up. So we can sort of just like blindly do something like this dot transform dot root dot get component rigid body. I guess we don't have to get component for the rigid. I don't know, we do. Now this is probably not slow. In Unity, like as of version, this is supposed to be really fast with caching. It's probably though a good idea if we do something like rigid body, ship rigid body over here, and offload this behavior over there. So we only grab the rigid body once instead of every single frame. It's probably a really good idea. And then over here, we say the ship rigid body, we're going to add a force at this position. I think at this point, we've got something that would work. So let's test it. Thruster, I'm going to put here, and I hit the space bar. Whoa, I'm getting errors. What's not set? Ship rigid body's not being set? Why 4 is that? Oh, thank you. Local, didn't must have had a warning and I just missed it. Or if I was using my style cop, it would have let me know. Thank you very much. So yeah, I was overriding things. I'll leave that error in there just in case. But now, because we weren't setting rigid body, we were setting a local rigid body instead of the one that belonged to the whole element. Let me try that thruster. Drop it here, and hit space. Oh, ship root is still kinematic. So I'm going to turn off the kinematic. Space. Hey, there we go. As expected, we're going the wrong way around. That's because the thruster's forward direction is, anyway, it's not the way that you imagine it. So we actually want the inverse. Now, transform doesn't have a back. Vector 3 has a back. Transform doesn't. That's okay. We can just put in negative forward. That will work out fine, or negative thrust or something like that, but that seems a little bit more awkward. So again, we'll drop a thruster on here. We will tell the ship root that is no longer kinematic. Hit the space bar. There we go. Bye. And let's try a slightly more interesting shape. I'm going to use a rectangle, do this, then throw a thruster on here. Then again, take off the is kinematic. We should probably make a button for that. What do you think? And spacebar. Wee! So it's clearly correctly working at the position of the thruster. Hooray! That's fantastic. All right, let's quickly make a button to toggle the is kinematic status. So how do we want to do this? Inside the UI system, I'm going to make just a button, UI button. We're going to drop that in the top right corner of our screen. And we are going to say kinematic. I don't think we can just toggle. So we'll make one that says to off. Oops, that's not the actual label. So when we click this, we are just going to tell the ship root and its rigid body component, we're going to set is kinematic to false. And I'm going to duplicate of this button. I'm going to move it down here. And I set kinematic to on. Copy. Paste. And then, oops, you've got to actually hit enter to lock in the name change. And then when the button gets clicked here, it's going to turn the rigid body or the kinematic back on. So if I go and say, again, we'll add a rectangle there. a thruster off to the side. If I hit spacebar, nothing happens because it's kinematic right now. So even though I'm still doing the force thing, which we could check, we could actually, it might not be a bad idea in here to like, if rigid body is kinematic, just return immediately. Actually, sounds like a really good idea. If ship rigid body dot is kinematic is equal to true, then we literally, there's no reason to do anything in here. So we'll just return right away. So spacebar does nothing. If I set kinematic to off and then hit space, set kinematic to on, it'll freeze it again because when kinematic is on, the physics don't do anything. So right now, all the thrusters use exactly the same key. So if I set kinematic to off over here and I hit spacebar, they'll both go. I'm just going to push it that way and then sideways as well. This is incredibly entertaining, actually. Set kinematic to on. Let's go and dolly our camera over there. Hello, dolly. Maybe we want to do something where if you're holding shift when you're moving the camera, it goes faster. That might not be a terrible idea. Maybe we could have a button to like set the camera to be wherever the route is, or maybe reset the ship position. It's very easy to do. You just set the ship route, set its position rotation back to 0. That might be a pretty good tool. I don't know. Maybe you want another thing where the camera will follow the ship. It's really easy to do that. Hell, there's built-in scripts to make that life easy. So lots of different options. We're going to cut this video here. We've been streaming programming for 2 hours now. We're going to take a short break. We're going to come back with video games. But if you do follow this series over at youtube.com/Quilly18Creates, the very next thing we're going to do is we're going to make it so that when you click on one of the thrusters here, perhaps right click, I'm sort of overloading the right click behavior, right? Because if I hold right click, we spin. But if I just say click right click there without moving it, what it should do, I think, on a thruster, it should open up a little window that asks you what key you want to bind this thruster to. So instead of all be bound to space, now we can override the thing so that one key is for this thruster, or even like if we do a series, right? If I go thruster here, here, and here, one key, you bind them all to the same key here, but bind this one to a different one in there. Now all of a sudden we got directional thrust, so we can mess around with things. So that's probably what we're going to do next, is do that. Of course, I did do a standalone tutorial for key rebinding. Basically, we're going to be doing a lot of the steps that we learned in there, but applying it in a very different way. The other one was like for a full screen of like, here's all the key binds in the program, and here's how you remap them all. Instead, what's going to happen here is we're going to rebind the keys for like individual thrusters in a more focused way. But yeah, if I go and say kinematic to off here and hit spacebar, whee! This is too entertaining. Let's make a slightly cooler looking ship here. Let me maximize. Excellent. Let's go and use rectangle, then rectangle, rectangle, like that, and then thrusters on the back here, like that. Kinematic to off, hit space. Vroom! I love it. I love it. I think it's great. Do the forces add up? Yes, they will, because each thruster is applying a certain amount of force, but they would definitely add up. So more thrusters equals more faster. Although the larger your ship is, the heavier it will be. So one of the things in the rigid body over here is there's that field for mass. Yeah, just open it in Google Chrome. And it's a little bit confusing because, okay, they've changed the definition a few times. I think that might be a difference from the old physics and the new one. It used to be that mass was not actually an indicator of the absolute mass of the object. Instead, this was something more akin to density, where it would add up the volume of all the rigid bodies and then use that. That may not be the case anymore. So you may have to manually do something like add to this mass number as you add more and more and more little body parts to this ship. That's entirely possible. I'm not sure. We'd figure that out later on for that. And of course, then you might want to also have with your ship parts is some sort of system for saying, well, the cube weighs this much, the rectangle weighs this much, and so on and so forth. You could also assume a equal density and instead look at their collision boxes and just based on the volume of their collision box, assume a certain amount of mass. That's something we'll have to figure out later if we're looking for something that's a little bit more realistic and a little bit more interesting. But yeah, if you're wondering what this big triangle is, that is our UI over there. All right, it's our big UI. If you want to hide that in the inspector view, you can do that from the layers tab over here. Just hide the UI. That will no longer show up in the inspector. but just remember to turn it on again if you need to modify the user interface, or like me, you'll forget that you've turned it off and just be very, very, very confused. It's better than No Man's Sky. Oh, excellent. Good stuff. So what we're going to do is we're going to take a short break, and when we come back, we're going to try Grim Dawn. Grim Dawn is an action RPG or Diablo-like game. It's made by the same people who made Titan Quest, which was a game I enjoyed a lot, actually. And some of those people are like some old Diablo 2 people as well, so that's quite interesting. I've dabbled with it for like 10 minutes. I got like, I don't know, maybe 30 minutes of playtime in Grim Dawn. So I really want to give that a go, see what it feels like. We'll play it for a couple hours. There won't be a multiplayer component today. But yeah, when we come back, we're going to play Grim Dawn for a couple hours and see what that's like. And if you did miss the programming stream will be up at youtube.com/QuillyKingCreates soon for, various values of soon. There's already previous episodes of this tutorial on there, which shows how we got to this point that we were at the start of today's stream, as well as tons of other tutorials if you haven't seen it already. The Grim Dawn component will be on my normal gaming channel, of course, at youtube.com/Quill18. But yeah. Short break. When we come back, we play video games. Cheers! See you in a couple. Thank you to all our September patrons, i.e. people who've pledged in September and are supporting the videos from October to early November, and especially these Mike Check supporters. We've got Yuko Finn, Ole Peter Talgo, Adam Conway, Drazian, Jan Torrevel, Adjective, Michael McClintock, Aaron Dobson, Craig Mortel, Stephen Wendell, Julien Auger Lafont, Marius Fieldvold, Speedy Savant, Stephen Stager, Valiant Cake Fiend, Wes Olenboving, Jason Yanity, Kale the Quick, Neil Blakey Milner, and everyone who's watched, shared, favored, and subscribed to the series. Thank you very, very much.